Hello, this is the practice exam. We're taking over the last part, or part B, part B, question 6. And the first part of it, first of all, you're given this concentration cell, or zinc on both sides, but you have different concentrations of the zinc. So this first one is the anode. Here's our cathode. If you want to write down the equation that's happening in each case, so at the anode, your zinc is being oxidized to zinc 2+. To balance that, 2 electrons. At your cathode, the opposite is happening. You have zinc 2+, with 2 electrons going to zinc. Now, you want to find the initial cell potential, so E cell, under these conditions over here. And if you remember your equation, Nernst equation, E cell equals E naught cell minus RT over ZF or NF ln of Q. So we need to find E naught cell. R is gas constant, we're at 298. We have to find our moles of electrons, which will be 2 because we just balanced our equation, and then Faraday's, and then Q. So E naught cell, first of all, remember that's equal to our cathode minus our anode. And you're given already the reduction potential of zinc 2+ to zinc being minus 0.76 volts. So that means for our cathode, it's going to be minus 0.76. And for our anode, it's going the opposite direction, or we have a minus 0.76. So this is just 0. Now for Q, the Q is our concentration of our products over reactants. So we have 2 different zinc concentrations, and I'll call this one here, so the one on the product side, zinc 2+, because everything else, the electrons don't count in there, and the other is a solid. So the zinc 2+ of the anode over zinc 2+ of our cathode. So Q equal to 0.1 over 0.5. So it's equal to 0.2. Now, back over here then, if you input all of this, so this is 0, right? That means we're going to have minus 8.314 joules per mole Kelvin, which is a volt coulomb for the joule, 298. Our electrons, we have 2 moles of electrons. And then Faraday's, which is coulombs per mole electron. And then ln of 0.2. So our E cell ends up being plus 0.021 volts. Now the second part of this asks us then, at equilibrium, what are the zinc ion concentrations at the anode and the cathode? So at equilibrium, remember under those conditions, E cell equals 0, Q equals K. So you go back into your equation up here then, you have 0 equals 0 minus RT over ZF ln K. So under these conditions here, that means that ln K equals 0, right? Because none of these are 0. So ln K equals 0. That means K equals 1. This means, remember K is my products over reactants. So it's going to be my zinc 2+ at the anode over zinc 2+ at the cathode. Those are now going to be equal. So if you think about it, my anode is 0.1, it's going to increase, my cathode is going to decrease. They have to be the same. And so you can say it's the same by about x. So if I have 0.1 plus x for my anode one, has to equal 0.5 minus X in my cathode. Working this out, you get a value of X equal to 0.2, which means that our final concentrations for both of these guys are going to be 0.3 molar.